Hey guys, in the previous video we went through the code of binary search, and in this one I want to go through a quick visualization. So here's the total algorithm. If you don't remember it, here it is, but hopefully you guys have already written the code. So what I'll do is that I'll start with our example in main, and what I'll do is I'll go through some examples. So the first example is that our value is going to be equal to 20. And obviously, if you see my mouse here, you see that it is in the array, but our code doesn't know that yet. So first, let's go with setting up our algorithm, and it begins with a setup of our beginning and ending iterators. So we set begin equal to 0 and end equal to v size. And I kind of set it up here that where here's where the indices would be pointing if you would access v. So if I did v of begin, you'd get 2. If I did v of end, you'd get 22. So then we enter our infinite while loop. So we then do our calculation of mid, which will be the beginning plus end divided by 2. Then we check if mid is equal to value. If it is, we return true. However, in this circumstance, our value is equal to 20, and 20 is not equal to 12. So we move on to the next part of our while loop. So then we learn if our mid value is greater than the value that we're looking for, we're going to say end is equal to mid minus 1. Otherwise, we're going to say begin is equal to mid plus 1. Well, our value is bigger than the v mid that we were accessing, so we're going to set begin equal to mid plus 1. And what you notice when I change the value of begin, I essentially drop off or kind of like cut off this part of the array. And this is kind of the neat trick of binary search, is that I essentially chop it in half with every search. My search always narrows down by 1/2. I mean, we need to go and recalculate mid, but we're not there yet. So we then check if we're at the end of our search. So we check if mid is equal to begin or mid is equal to end. Obviously, this is not the case because mid is equal to some other value. So then we end our while loop and we start it again with the next iteration. So we recalculate mid. So now mid is pointing to the index of where 20 is supposed to be. So then we check if v mid is equal to value. And hey, you know what? We have a success. This is true. So our value is equal to 20, so we return true. And that's the end of our search for value equal to 20. And for this, it only took 2 comparisons. We only compared 12, which is in the middle here, and then we found 20. If we compare this to linear search, we need to look at 1, 2, 3, 4, 5, 6 values in order to see that. So binary search works pretty fast. With that, now let's work with a value of 25. Let's look for 25. So again, we set up our iterators, begin and end, and then we go into our while loop and we calculate mid. We see that mid is not equal to value because v of mid is 12 and the value that we're looking for is 25. So we continue with our while loop. We cut our vector in half and we change the position of mid. We know that we're not at the end of our search, so we continue again and we recalculate mid. And here, in the last example, here's where we end. However, this is not the case. 20 is not equal to 25. So then we need to go and we need to recalculate our mid. So since 25 is greater than 20, what we're going to do is that we're going to change our begin to mid plus 1. And if you notice now, begin is equal to end. So we check if mid is equal to either end or begin, which is not. So then we keep going with our while loop. So we recalculate mid, which is it's a little weird because they're all the same number now. Begin, mid, and end are all the same number. So now we check if v of mid is equal to value. Is 22 equal to 25? No. So we continue with our other if statement and we increment begin. It's pointed to somewhere. It's pointing into weird stuff. We probably shouldn't use begin again. And then lastly, we check that if mid is equal to end or begin. So in this case, mid is equal to end. So, too bad, so sad. 25 is not in our vector v. So this search has ended in failure. Next, I want to go to the other side of the search. In these previous 2 examples, I went right, and now I'm going to go left. So the value is going to be equal to 1, and we're using the same array. So unfortunately, 1 is not going to be in our vector v. But we're going to run through the algorithm to see how it searches. We saw how it searches on the right side. Now we're going to see on the left side. So we calculate our mid just like before, and we compare our middle to our value. So we look at 12, which is V mid, and we compare it to 1. If it's not the case, well, we need to see if V mid is greater than 1. And it is. 12 is greater than 1. So what we're going to do now is we're going to change end to be equal to mid minus 1. And we essentially chop off this half of the array. We continue. Is the mid equal to the beginning or end? No. So we recalculate mid, and we check if V mid is equal to the value that we're looking for. 5 is not equal to 1, so we got to evaluate and see, okay, where do we need to change our beginning or end? So 5 is greater than 1, so we change end to mid minus 1, and then we need to check if mid is either at the beginning or at the end, which is not. So then we continue with what is going to be our last iteration of our while loop, where we recalculate mid. Begin, mid, and end are all pointing to the same value. Then we check if V mid is equal to our value. Unfortunately, 2 is not equal to 1. So we go and we update end, which, it's pointing into some weird place. Some place before 2. The first element of a vector, it might be pointing to 0, some 0 data or junk data, or maybe another data structure. We don't know. So finally, we check if mid is equal to begin or end. And in the last case, mid was equal to end, and that's what triggered the failure in the search. However, here, begin is equal to mid, and that's what's going to trigger our failure of the search. And that about wraps it up. For you as an example, maybe go through and look at a value like 7. If we were searching for 7 or 16, go through the algorithm and kind of check it out and see how that would go. That'd be an interesting exercise. And with that, I'll see you in another video. Take care.